So, welcome to another episode of BetaTalk. I'd like to thank this season's sponsor, which is Intergas. And while I'm talking about sponsors, this is my 12th season, and I've had 12 sponsors individually sponsor season. I'm very grateful to them, but I'm changing things up a bit. So, some of you may have noticed I'm imminently going to be launching a newsletter and associated website that will feature case studies from the Guild of Master Heat Engineers, and I will be having a consortium of sponsors for that. So if you're interested in getting involved in that, contact me. I'll put a link in the show notes where you can subscribe to the newsletter that's going to be coming out, as I say, imminently. And also, you'll be able to see the quote that Chris Stark, obviously most of you will know Chris Stark was the former CEO of the Climate Change Committee. He wrote me a lovely little quotation about this new media venture that I'm undertaking. So you can go and have a little read of that. So today we're going to be talking air to air. You'll all know that I'm a big sort of advocate of air to air because my family have been doing it for decades. So one of my guests today is Michael Cosham, who's also been doing it for decades. He's been installing air to air stuff for around about 47 years, I think. We'll chat more about that to Michael. We're also joined by S and I have been communicating for a number of years now on our social media channels. Some of you will be familiar with him. He does work around sort of the Passivhaus sector, and he has an air-to-air system in his home. So we're going to be chatting about that. It's a well-known system. It's on the Open Energy Monitor site, and I think he had the lowest running costs for a heat pump system on that site, and that's obviously something we'll be touching on as well. So welcome to the show, guys. I'm going to come to you first, Michael, because as you're aware, you and I have been trying. Well, I've been trying for years on social media to help people understand that heat pumps literally are everywhere on this planet. I mean, there's estimated 5 billion compressors on this planet running all sorts of things. Heat pumps aren't something to be scared of. They exist everywhere. I don't think people realise that. So if you go back to the days of DEC, the Department for Energy and Climate Change, when they which predates Bayes and obviously DESNZ, I think it's fair to say that when their civil servants were all chatting about heat pumps, I don't think they realised they've been in existence for a long time. They're everywhere. They would have been in the offices that some of them were working in, keeping them either hot or cool. So you've been in the industry a long time, Michael, haven't you? How did you get in the industry? What do you sort of specialise in at the moment?
I tried to get into some sort of mechanical work when I left school, and I went for a couple of jobs. Fortunately, I didn't get them, and someone my father knew just up the road, there was a small manufacturer, custom built refrigerated and heated display cabinets and cold rooms, so light commercial refrigeration, and they had a vacancy. So I went into there, and like most school kids, nobody knows about refrigeration or wants to go in the industry because or back then anyway, people didn't realize it existed. They had a fridge at home, and they used the fridge at home and thought nothing more of it. And so, yeah, my eyes were opened because I was quite practical at the time with electrics, electronics, and woodwork. So, and it was all this stuff I went into was all hand built. It was quite interesting, quite a few trades in there. And I picked up most of my skills for the rest of my life from that company in Essex. And yeah, we did a bit of air conditioning in the early days when it was big and noisy. Um, but I soon found out sort of the connection with heat pumps is what a waste of heat, such as you may have climbed on cold rooms yourself to sorting out condensers in the past or whatever that's covered in dust. In butchers, where we used to blow them out with a gas and probably was illegal to clear them off. And I used to think, what a waste of heat. It was so hot up there. And that's when I moved on to trying to make my own heat pump. Not the idea it was called a heat pump. I just saw it was waste heat and it had a use. So that was my beginnings. So I'm very practical. I've changed a bit with the times, not necessarily with the regulations, but I've got I feel quite a lot of experience in what's happened since 1977 or thereabouts. And mainly now I do what makes the most money, which is air to air, beer cellar cooling.
I was going to say, you do a lot of cellar cooling. Just for the listeners, just explain, because again, this sort of highlights that heat pumps are. I mean, there's loads of heat pump systems in every pub. I mean, like you say, all the cabinets that have got their bottles of beer in, heat pump systems. But you do cellar coolers, don't you? Just explain for the
Yeah,
listeners what a cellar cooler is.
I started a separate company for that about 15 years ago because it was so popular. And people often think if you've got a name in your business and it says, say, air conditioning, they don't think you do heating. If it says heating, they don't think you do cooling. So I just started a new business that was called Cellar Cooling UK. And all the cellar cooler inquiries went through that business. We was installing about 90 a year up until recently, where I've cut it back because I can't handle it. And again, that's, I won't say easy money, but it can be. Simple jobs, indoor unit, outdoor unit. One removes the heat from a place where you don't want it, which is the beer cellar, and chucks it outside generally from the outdoor unit. So similar to aircon, just a bit more commercial.
Is there a legal obligation for pubs to have the cellar at a certain temperature?
No.
No, it's just something they do.
No, but if they don't have it, then the beers will fob and they'll
Yeah.
come out the pump at sort of room temperature, and it'll be 90% froth and 10% beer. So there'll be a lot of wastage. So as far as they're concerned, it's about reducing wastage of the beer. So if it's kept at 12, 13 degrees, then it will be at the right temperature, and then the flash coolers just take it down a bit cooler. And it's served as you'd want it to in the pint glass.
And am I right in thinking, did you put an air-to-air system in your own home? Did you used to live on Canvey Island?
I lived on Canvey Island. That's my first home because at the time it was a cheaper place to live than where I was living with my parents in Essex. It was quite a lot cheaper actually. So we bought a bungalow on there that had a warm air gas. Well, I'll call it a boiler. It wasn't a boiler. It didn't heat the hot water. It just heated like basically a dustbin, like a copper dustbin, and the heat from that just rose through the vents in this central location. Quite popular in the 70s, I think, some places. And the heat just petered out into other rooms, and it wasn't very effective. So I just ripped that out and made a heat pump out of a condensing unit and some condensers with fans that I put in there. Quite amateurish, but it was an experiment and it did work. I don't know what its efficiency was like. I don't suppose it was brilliant, but it removed the heat from outdoors and put it indoors where I wanted it. And that was about 1982, I think, I did that.
Well, obviously, some of my listeners will know. So Canvey Island, as you would know, was the test bed where they piloted natural gas, and of course, it's
Yeah.
also where the world's first ship that was capable of transporting methane docked. It brought that methane across from America to Canvey Island, and it then started to bring it from Algiers, I think. But so yeah, sort of lot of history, Canvey Island, in regards to sort of the heating industry.
Mm.
Ez, so you just explain what you do. Obviously, like I said in the intro, you and I have sort of chatted over the years on our social media. It's the first time I've had you on the podcast, so I'm pleased to sort of chat to you finally about what your job role is and how you're involved in this sector, and also about your air-to-air system that you've got at home.
Yeah, thanks very much for having me on. I'm excited to be here. So I'm a passive house designer based in Scotland. I live near Fort William, up on the west coast of kind of western Highlands of Scotland, just with a view of Ben Nevis out the front window. I work half my time for some architects in Glasgow called John Gilbert Architects. And they're architects specialising in heritage and in low energy, high performance buildings. And for them, I do passive house stuff on their complicated buildings, so leisure centres and schools primarily. So I've got a couple of passive house standard leisure centres at the moment, which are really interesting, like looking at how to really radically reduce the energy demands of leisure centres with swimming pools is really challenging, but like massive wins to be had there. And then the rest of the other 50% of the time, I work for my own company called Highland Passive, and where I'm focusing on retrofit of timber frame houses, but basically similar to what I did in my own house. Primarily, that's what I'm trying to do on the half the days of the week that I'm working for Highland Passive, is trying to take projects that are similar to my own house, because that experience was so valuable and transferable, because that type of housing is pretty ubiquitous in this part of the world. Like, I guess since 1980, the vast majority of new houses built since 1980 in this part of the world are timber frame structurally, usually with a rendered blockwork on the outside.
Well, I think of it. So these leisure centres, then, I mean, what sort of heating systems are going into them? Are they things like VRV systems, or what's going?
So they're heat pumps, air-to-air heat pumps, and you usually have a different sort of heating system for different parts of the building. So a big part of the focus, a big part of the fabric focus is looking at separating the building into temperature zones and trying to minimize the heat loss between temperature zones. Because you'll have, for example, a learner pool. The pool hall that's got the learner pool in it might be 33 degrees, 32 degrees Celsius. And elsewhere in the building, there might be a gym that's 16 degrees Celsius. So you don't want them next to each other if you can avoid it. And wherever you do have a high temperature difference, you want to have some good insulation in the elements between those two spaces. So we've got a mixture of so I'm trying to think if it's the same on both the projects I'm working on. I think it is. We've got air to water heat pumps heating most of the building, and then we've got the same sort of heat pump but supplying the heat via the supply air into the swimming pool halls, for the pool halls. And much more so than like domestic passive house has a very strong, like, most of what you have to do is most of what you have to do to make the buildings perform really well is focused on the fabric, and the M&E is important, but it's not as difficult to do as the it's not as difficult to achieve as the fabric requirements, I would say, in passive house. And there's maybe we could discuss that maybe the requirements for the M&E should be more stringent, but certainly in non-domestic buildings, the M&E is like the big thing in terms of the energy use, especially like looking at ventilation rates and things like that. The ventilation especially is like getting that right is really, really crucial. You can make a massive impact on the energy use of the building by getting the ventilation right, especially in swimming pools, because your energy demand for heating the pool water depends primarily on the evaporation rate from the pool, and how you ventilate the pool hall. You can really radically reduce that evaporation rate if you do it in a certain way.
So I suppose coming back to a point Michael mentioned about this waste heat, we've got millions of condensers all over the country
Yeah.
pushing heat out into the atmosphere. I mean, the things with leisure centres, you're going to have rooms that need to be warmer than other rooms, and you're going to have sort of, let's say there's a spin class going on in a leisure centre. That's an awful lot of body heat, and with a VRF heat recovery system, you can then move that body heat and put it into another room within the leisure centre, rather than actually chuck it out.
That was something that jumped out to me when Michael was talking about getting the heat out of the beer cellars. I was thinking, can you not heat the house at the same time, or heat it? So we do some of that, and yeah, one other way of doing it is is it a VRV or VRF? I can never remember which one.
It's exactly the same. It's just that Dakin, who invented it, had the trademark rights to VRV. Everyone else has to call it VRF, but it's the same.
Right. Okay, so sometimes we have those systems where you can have the same system heating one zone and cooling another at the same time.
Yeah.
We have some of that, but actually the fabric is so good, the air tightness is so good, and the ventilation heat recovery is so good that there isn't like a constant heat source. There isn't a constant heat requirement, and especially when the cooling requirement is at its maximum, it might be that even the pool hall doesn't need any heating for like several months of the summer, and the pool water doesn't need any heating for several months of the summer. because that system is so much more efficient than in a conventional system. So having the system set up to reject heat into other zones isn't necessarily the best idea in that kind of super efficient building. So what we're but conversely, they have a very high domestic hot water demand for showering. So often we're saying, actually, can we use the heat from the cooling? Can we put that into the hot water system? Um, because that's a more constant demand.
Yeah, I did a podcast recently with a guest who makes the cylinders, so where you can take that waste heat and then use that waste heat to heat your hot water.
Right.
So the core going around them cylinders actually contains refrigerant.
Right. Yeah.
Before I forget, just for my listeners, just explain as simply as possible, let's say in a sentence, what passive house actually means. I'm sure a lot of my listeners will know, but just for
Yeah.
anyone that doesn't.
Yeah, so Passivhaus is an energy and comfort standard, and it started as a standard for domestic buildings, and it's agnostic about how you get to this point, but you have to meet a modelled annual heating demand of less than 15 kilowatt hours per meter squared per year, um, or a peak heat load of 10 watts per meter squared. This is a floor area, and as an idea, that's probably 5 to 8 times better than a typical building regs new build now. Um, and you also have to have very good air tightness. So you have to get an air tightness of below zero point 0.6 air changes per hour at 50 pascals. It's not the same metric, but actually the numbers are almost exactly the same on a typical house. So quite an airtight new build might be 3, and we're going for 0.6. So um, we're kind of like 5 times better than quite an airtight new build. And then we've got really good the things that it takes to get to that 15 kilowatt hours or 10 watts per meter squared is really good insulation, continuous insulation with no thermal bridges or minimized thermal bridges, really good air tightness, triple glazed windows, and thinking carefully about size of windows, orientation, shading, uh, heat recovery ventilation, and then how you heat it is sort of up to you. You have to meet um, an overall energy demand target that includes the all the heating and all the other energy, and that's quite hard to do now with either direct electric or gas. But it is possible, and I would say that for domestic, that would be my one criticism, is that should probably be tightened up to make it more stringent on the heating, on the type of heating that you can put in.
And for also for the listeners, obviously, passive house is usually associated with new build, and obviously with retrofit, we have this term enefit, which is
Yeah,
similar, but just a sort of a bit more of a workable.
yeah, yeah. So yeah, new build. So I said it started in housing. It's now also branched out into other types of non-domestic buildings. So it's having really good success with schools, especially in Scotland, due to some kind of legislative changes and funding changes. They've done hospitals, they've done large apartment buildings, student accommodation, leisure centres is the kind of frontier at the moment, I guess. And leisure centres and hospitals are, as like massively energy hungry buildings. But then, yeah, from a retrofit point of view, getting to that 15 kilowatt hours per meter squared per year or 10 watts per meter squared peak heat load is very challenging on a retrofit, often impossible, and yeah, extremely challenging. And so there's a slightly easier standard to get to called Enefit, and that's for most of the UK, that's 25 kilowatt hours per meter squared per year. Or that actually is very difficult to do as well, unless you're going for external wall insulation. So if you're doing so there's another way called so the shape of your building has a really big impact on the heat demand, which isn't generally recognized by the way that building regulations looks at energy. Um, and unless your building is a really good shape and you can do external wall insulation, it's very difficult to get to 25. So there's what's called a elemental option where you have to hit certain U values for your walls, certain U values for your roof, certain U values for your floor. And if you're doing it internal wall insulation, those U values are considerably higher. So for internal wall insulation, for NFIT, you only have to hit 0.35, a U value of 0.35 for the walls. And that's what I did on my house, was an elemental approach. I was retrofitting from the inside. So it's not a standard internal wall insulation situation because it's a timber frame. So I was able to take plasterboard off and insulate between the studs. But it was a skinny timber frame. It's only like 100 mil deep studs. So I was adding insulation and then adding another 40 mil of wood fiber board insulation inside that. So the U values on my walls are actually not very low. They're like 0.27. And then upstairs we did a new build bit, basically, that is kind of Passivhaus new build standard. So yeah, the retrofit standard for Passivhaus is slightly different, but it's the same idea, basically, like trying to make your insulation as continuous as possible, trying to make the building as airtight as possible, putting in triple glazing, putting in heat recovery ventilation, and the air tightness target is easier to achieve as well. It's 1 rather than 0.6. Yeah.
So I'm going to come to you in a minute and chat about this air-to-air system that you've got in your own home. And going to come to you first, Mike. Now, Michael, you and I, well, everyone really, social media is kind of a new thing for all of us, really, isn't it? And because you and I, well, everyone is, we see lots of discussions about an industry you and I have kind of grown up in. So I just want to get your take on what I mean, you would have probably started back in the days of R11 and R22 and ammonia and stuff like this. What are the sort of changes you've seen in your industry, and obviously now that everyone's talking about the industry that you've been involved in for so long? What are there any things that jump out to you, or any messages you want to help people with to understand? What have you sort of seen on the social media lately?
I think the biggest changes, which have been going on probably since the 90s, is the change of refrigerant gas. And every time a new one comes out, this is a new brilliant gas, superseded next year or whenever by the next brilliant gas, which, let's face it, CFCs were great gases, compared with what we had before, which were all toxic or flammable. So we moved over to, say, 12, 502 and 22 for different applications. They weren't flammable, so that was a good step. They weren't toxic unless you burned them. And then we moved over to interim gases with loads of different numbers. So instead of having 1 or 2 gases in your vehicle for servicing and repairs, the van was bigger and fuller of gases in case you needed them on this next project you went to. And then now we've gone to, say, on aircon, heat pumps, 407, 410A. And that was the new wonder gases as well. And now 410 is frowned upon as well. It's a nasty bit of gas for the warming potential. So we come down to R32, which is what I call barely flammable, because I haven't been able to burn it. Don't repeat that to anyone. and it's hard to burn. So it's barely flammable, but there is a potential. It's still, 749 or something. So it's still global warming potential. It's a bit more than they're looking to go to in a few years' time. So let's bring out a gas that's super flammable, R290. It does have some benefits over, say, 32. Time will tell how explosive it will be. But the industry, I think, will literally explode with R290 because there's been so many people getting on this bandwagon of let's fit in heat pumps, even now going to aircon. I actually saw electricians, and nothing against all these other trades, by the way, because we all do other people's trades as well. It's an electrician's fan and said, we now also fit air conditioning. Oh, so you've done a 3 or 5 day course, you've got your F-gas, you can legally buy it, and you can probably put it in and you're probably okay. Maybe not when it goes wrong. You probably won't have a clue. And installation is fine on a modern type of house, for instance, with a short pipe run, but anything more complex than that, like the churches that we do a lot of churches for heat pumps. You've got a wall that's a metre thick and takes all day to drill it, just to get the pipes through. you'd probably give up on that. But when these people go over to R290, I think there's going to be some issues, and I think if there isn't any proper regulations to have to qualify, and you don't really have to have a qualification. You can buy it without F-gas. You can fit it without F-gas because it's not an F-gas. And there's F-gas regulations were all about containment and reducing leaks. There obviously was an issue with leaks in the past, so those leaks will still continue when we have R290 in every bedroom in people's houses. And if it's not been installed by someone who's competent to do that, well, we'll see. We'll see what the future holds. So I think there's been the biggest changes in the industry is the gases. They keep changing.
Yeah, it's exactly what my cousin has been doing it sort of similar, sort of maybe even longer than you, but it's exactly what he would say is, you've got all these what you would call interim gases. He calls them drop-in gases. So they were a gas that you used for a few years, and everyone knew that would eventually be changing, and everyone would have to use another one. And of course, what it usually meant for all you guys is you got to change all your equipment. You got to change your vac pump sometimes and all this sort of stuff, haven't you? And obviously some compressor changes on machines don't take the new gas, so you have to sort of accommodate for that. So Ez, you've got a mini split, I believe, in your home. Tell us about that. What make have you got? Is it a Mitsubishi, I suppose?
It's a Mitsubishi, yeah. I can get you the number if you want.
No.
I can't remember off the top of my head.
It's an
the
numbers.
R32, and it's the smallest Mitsubishi one that we could get. I think it's rated at 2.7 kilowatt heat output. And that's in our dining room, and we've got like quite a square floor plan. So the dining room is open plan to the kitchen, and it's opposite the door that goes to the living room. So when it's on, it's also quite good at throwing heat into the living room. And then upstairs, it's kind of close to the bottom of the stairs, so the heat also goes upstairs quite well. But basically, we were able to do that because what we've done to the fabric is so radical. Like our peak heat load is about 1.3 kilowatts, which, in this part of the world is we're pretty far north.
Are you a -5 design temperature? What's your design temperature?
Let me have a look actually. So the way Passivhaus, the way PHPP does it is different from it's not. So that 1.3 actually, it sounds more impressive to someone like you than it actually is, because it also includes, it's a 24-hour average, which is maybe the same as what you do, but it also includes solar gains, which you wouldn't normally include. Although actually the solar gains in the middle of December are pretty piffling in this part of the world. And it does two checks. So it does a very cold but not cloudy day, and it does a overcast but not quite so cold day, and it takes whichever of those is the higher heating load as your peak heat load. So let me just see so yeah, it's only zero actually, minus point 0.1 the average temperature for the whole day in PHPP. So we do definitely have colder days than that. We're down to like -7 last winter was our coldest day, but it probably wasn't -7 on average on a 24-hour average. Probably the -7 was the lowest it got to. So yeah, so because the heat demand from each room is tiny, you're able to meet the heat demand of that room just by heat leaking from neighboring rooms.
Yeah.
And that, I don't think it'll be interesting to hear what Michael says, but I would be wary about putting a system like this in a normal house, because we don't have any local heat sources in the rooms. We've just got this air-to-air mini split in one room, and that's keeping the whole house at a nice temperature.
There's probably quite a few properties that could have. You've got a wall-mounted unit, I suppose, for your internal unit, haven't you? And
yes, yeah,
there'd be a few homes that are relatively small. They might be detached, but only a couple of bedrooms upstairs. You could have a unit downstairs, because a lot of them would be open plan, and then a unit upstairs. And yeah, because this is forced fan convection, isn't it? So the heat is actually getting around a little bit quicker than the laws of thermodynamics would actually push it around. But
yeah.
And how have you found it? How long have you had it in?
2 winters now. So
Right.
we moved back in 2023, April 2023.
And everyone all nice and toasty up near Ben Nevis.
Yeah, yeah. I mean, it's like, I mean, the house is completely different to any house I've ever slept in before. Like it's amazing. It's really quiet. There's very little air movement. You don't. It feels very calm, and it's always a nice temperature. The rooms do, like, at nighttime we'll close the bedroom doors and the heating will stay on in the winter. The heating will stay on downstairs, um, and the bedrooms then will drop in a kind of typical winter weather to a degree or a degree and a half cooler than the rest of than the room where the heating is being delivered.
Which is actually quite nice for a bedroom, isn't it?
Which exactly, yeah, for a bedroom is what most people prefer, and certainly is what we prefer. Um, and it means that we can actually, I'm on Octopus, one of the Octopus tariffs that's very cheap overnight. So actually, I overheat the dining room for the 5 hours a night when I get 7 pence a kilowatt hour electricity, and I can do that without making the bedrooms uncomfortably warm, which is nice. In the coldest weather, so the week where it went to -7, I put a post on LinkedIn about this last week. I think the coldest the bedroom got to was 17. So it's still pretty good. I think that week I had to put, like, we when we moved back into the house, we quickly realized we weren't going to need the winter duvet ever again. So we got rid of the winter duvet and we have a summer duvet all year round. And I think that -7 week, I put an extra blanket on, and my wife didn't. She sleeps a bit warmer than me. So yeah, it's been amazing, basically.
There's three questions that have popped into my head, so I'm going to just mention them before I forget them. So one is around noise, and I'll talk to you about that if you think they're noisy. There's another one about some people suggest that they don't like air-to-air stuff in their homes because they think it will dry their skin, and they sort of, and I suppose they sort of are thinking about the work environments, the office environments they're working in where this stuff is heating them. And then the other thing I think my listeners will want to know, how much did your system cost? And then I'm going to, because one of the things I always put on LinkedIn is, a little tiny mini split air to air. I'll ask you how much you can get for in a minute, Michael.
Yeah.
But how much did it cost, Ez?
So fully installed, it was £1,500.
Yeah.
But then I had to have a hot water system as well.
Right. Yeah. We'll talk.
So,
about that.
if I was going for an air to water, that would do the hot water as well. So
Yeah.
I've got a hot water heat pump that's actually stealing heat from the house. It's not ducted to outside. It's one of these. It's a Valent one, and Dimplex do a similar one, and I think Mixergy do a similar one. And that was 2,500. So I don't really know what the installation cost of that was, because that was all tied into, like, them redoing the plumbing, the plumber redoing the plumbing. But yeah, 1,500 for the air-to-air installed, plus 2.5 for the hot water heat pump.
I'll come to you quickly, Michael. How much could you buy a 2.7 kilowatt Mitzi split mini?
You'd be looking at around £400.
Yeah, they're not dear, are they? So when people say heat pumps are expensive,
and the Mitsubishi ones are one of the dearer ones. So you can get them for less than that. Just want to pick up on something you mentioned about people saying drying their skin. Well, we mainly fit Panasonic, because they've got a built-in air purifier, and that reduces any. And this is heating or cooling, or not even, or neither. You can just have the air purifier on just to help with the skin. I don't know the full details of how it works. It's quite complex, but it's a proven technology, and it reduces, say, dry eyes and dry skin just by having. It's called Nano X. It's a patent from Panasonic, but you can have that on without the heating or cooling. So it will reduce the problems. People say, "Oh, I don't want to dry throat or dry my eyes out." Often that's down to bad management of your system. Now, you described a system you've managed really well, such as your cheap rate Octopus energy. A lot of people don't bother with this sort of stuff. They just bung it on when they think it needs to be on, take it off, and then the house goes up and down on temperature. Same with the dryness, humidity levels. It's because they don't manage it, or they're not shown how the best way to operate any system is. But going back to the Panasonic ones, they've got the air purifier in there, so if you run the system properly, such as the lowest fan speed on a reasonable temperature, you won't notice. You won't hear it, for one thing, and you won't suffer from dry skin, sore throats, and
we'll pick up on fan speed in a minute, because that's obviously something perhaps people aren't aware of. So if you're fitting Panasonic, you would have been aware of AMP that got bought by Panasonic. Can you remember AMP, the merchants?
We've only been fitting Panasonic since COVID, because
Right.
so
Okay.
many people asked about the. I do remember them, by the way, but I don't know anything about it. Yeah, since COVID, people wanted air purifying to make the place healthy, which it does. It does remove COVID over a period of years. Hours. and same with other viruses, bacteria. It does remove those if you leave the air purifier on constant, which is basically just the fan running, no maintenance. It will remove those things.
I'll just mention AMP quickly for my listeners, because it's something I've used to help people understand that this stuff is ubiquitous, and the UK's got the largest commercial heat pump market in Europe, which is why Panasonic bought, which is a massive Japanese company. I think they're Japanese, and which is why they bought AMP. So AMP was basically set up by a gentleman that was in the merchant world selling air-to-air stuff, and he wanted to go on his own. And my cousin was buying stuff from the merchant he was working at. And when he was going on his own, my cousin said, well, look, I've got a big order coming up. I think it was the order for Classic FM, which we put possibly the world's first radio station to use VRV system. We put that system in, and then or it was either that one, or my cousin then flew out to Russia to put air-to-air stuff in the largest film studios in Russia. So he had a massive couple of orders, which helped AMP become quite successful, and it did become successful, become a national merchant. And when Panasonic were looking for merchants to acquire, they picked AMP, and in their literature at the time, I can't remember when they did, about 2017 or maybe later, they basically said, we've picked AMP because UK has Europe's largest commercial market for this kind of stuff. So people everyone always talks about Norway and Sweden as being these sort of the world leaders on heat pump technology. Commercially, the UK has been putting it in far longer than any other European country for a long, long time. Now, Ed, I want to come back to this noise issue. I want to ask if you find it noisy, or do you find you've got problems with sort of the air quality making your eyes dry?
So noise one first. No, very occasionally, if I'm sat at the dining room table on my own, I'll turn it off. Sometimes we'll turn it off at dinner. But the house stays warm so well that doesn't matter. It doesn't matter if it's off for an hour or so. But partly the reason that it's not noisy for us is that it's not doing very much. It's running quite a long way below its maximum output. Generally, it's just ticking over at like 250 watts of input electricity. And actually, so I'll come back to some of the things that haven't been so good about it that I think are probably quite easy to improve. But then the dryness, we haven't had any of that, and I'm curious as to what causes it, because it's not taking any moisture out of the air; it's just warming it up. So the relative humidity will go down of the air, but only very locally where it's blowing that very warm air on you. So maybe if you're stood close to it, it could give you a dry skin problem or a dry eyes problem. But I would have thought that would equalize quite quickly around the house and just be the same as running radiators in terms of the impact.
It would only be within the room you're in.
Okay.
I've got air-to-air in my own home. I've got 3 units, bigger than yours, but then not insulated as well. And the house, I don't know. It may be bigger, I don't know. Obviously in the warmer part of Scotland, down south. It is only if you're nearby, or it's been poorly placed. For instance, some people have them. I'm at a desk I hardly ever use because the computer's here today, but I could have one above me and it'd be a stupid place to put it. Where sometimes they go. So you've got the warm air or the cold air blowing on you. And think, that's fine in some weathers, but after half an hour or so, that will become irritating. It will dry your skin because you just evaporate your moisture on your skin.
I can see that.
And that's how it dries your skin. Does it more in cooling mode, does it in both modes. So
Yeah, yeah.
it's about placement, and like you manage yours, but fan speed. Some people just put them on the highest temperature or the lowest for aircon, and then they put maximum fan speed because they want it to do a job quickly, which it will do, but then they don't really alter it, and they leave it like that. Oh, it's so cold in here, or it's so hot, or it's blowing on my face, and it's really poor management, or maybe no one's shown them how to use it. The installer perhaps didn't show them how to use it properly.
Yeah.
At 19 decibels, which is what most of them are on the quietest, it's noise is rarely an issue.
Yeah, it's definitely not an issue for us. It would be like I wouldn't have it in the room I'm sleeping in, put it that
No,
way.
yeah.
But otherwise, it's not a problem.
Well, we do a lot of
Um,
landings are a good place to put them, and then most
yeah,
people do leave their doors open all the time. Maybe not the bathroom doors, but most of the doors are left open most of the day or night, and
yeah,
they're just transfers as you.
yeah. So, so the things that have been less good, and some of this is related to air movement and noise, is that when it's working at its best, it's great. It's just ticking over at say 250 watts of input electricity, and it just ticks over all day, and then we boost it at night to maybe 500, 600, and it'll overheat that room a bit, and then it'll go back to 250 during the day. Um, but it's not very good at super low loads. It cycles at very low loads. So our unit won't go below about 215 watts of input electricity before it switches off. And it switches off and then it comes back on. When it comes back on, it doesn't come back at the level it was at before. It comes back on at like 600, and then it drops down steadily, and then it switches off again, and then it comes back on at 600. It does that every 5 minutes, which is annoying, and it's also less efficient. You're getting it's hard to measure, but I'm pretty sure you're getting a worse coefficient of performance when it's doing that. Um, and I've got some ideas of how I'm going to fix that for next winter using a Raspberry Pi and Home Assistant setup, but it should be something that works off the shelf. I know that there's a guy, I've forgotten his name. Let's see if I can find him for later on. But there's a guy who's also done some good blogging about his air to air, and his I've spoken to him, and his modulates his I think is a more expensive Mitsubishi unit, and it modulates down to about 100 watts or 120 watts, which is much better than mine. So that would help. But it would also help if it was just smarter about how to manage those low loads. And then the other thing that has been less good is it's very poor at hitting at knowing what temperature it is in the room, and it gets worse at knowing what temperature it is the harder it's working. So I'll tell it that I want it to be 20 degrees in the room, and if it's like 8 degrees outside, it will get to 20 pretty fine. But then if it's let's say it's 0 outside, it's still trying to hit 20. It's way below its maximum output, so it's not that it's undersized, but it thinks it's at 20 when it's actually at 18, because the harder the units work, because the thermostat is right next to where the heat's being delivered. I think this is what causes the problem. And so the harder the unit is working, the warmer it thinks it is in the room, if you see what I mean. And so in very cold weather, I have to tell it, if I want the room to be 20, I have to tell it I want it to be 22.
Yeah.
And then when it gets milder, I'm going to have to change the thermostat back down to 20 to keep it at 20. And that's also annoying. So those are, and again, I'm hoping to solve that with this kind of
So the
Raspberry
control
Pi.
you've got there, yeah. So are you saying that's the handheld remote control that you're using to
Yeah,
control it?
exactly.
Okay.
But that's not where the thermostat is. The thermostat's in
No,
the
no.
in the unit.
Yeah.
So yeah, but that's the only control I have of it.
Yeah.
Yeah.
That's fine. I just wanted to check it wasn't a hardwired controller somewhere, because you have to set them up for where they read the temperature. But yeah, there's obviously reads the temperature in two places on that indoor unit, the airflow and the coil temperature, and it
Right.
corresponds with
Yeah.
the temperatures that two sensors are reading, or maybe three sensors on some of them on the outdoor unit. And if it was maybe the more basic version, that all these manufacturers normally do 2 or 3 versions. They do a basic, a middle one, and a top of the range. If it was the basic one, it probably doesn't modulate it as well as, say, the middle or the top one would do, which would have cost maybe a fair bit more, and you wouldn't have necessarily got much more out of it.
Yeah. So it may be that that's easily solved with just a better unit. The guy I was meaning is called John Eubank. He's written some useful stuff on it. And then the other thing that I would change about mine, which I suspect is also solved by having a more expensive unit, is the programming. So I can tell it I want different temperatures at different, like 4 different schedules during the day, I think, and I can schedule them for different days of the week, but I can't, for example, if I go on holiday, I can't tell it I want it to come on 2 days before I get back and warm the house up. And that's a pretty basic thing that's available with
Can you control this from a phone app?
No, at the moment I can't. No. So okay, with a more expensive unit, I could have done. Okay. Yeah. So that was quite interesting actually. We went away on a winter holiday in like December, January, and when we came back, I realized that the way I was thinking about the sizing of the unit was wrong. So I was thinking, oh, it's 2.7 kilowatts. That's more than my peak heat load of 1.3, 1.5 kilowatts, whatever it is. That will be fine. But actually, the limiting factor in how fast it will heat up my house isn't the size of the unit, isn't the power of the unit, it's how quickly it can get heat into the other rooms. So when we got back from our holiday, the house was maybe at 14 degrees, 13 or 14 degrees. I can't remember exactly. And it took like 3 days before it got to all the rooms being comfortable because it's
a tiny little unit, a much bigger space than it's designed for.
Well, not just that, but like the unit wasn't working flat out over that 3 days. The limiting factor was how quickly it could get, the rate at which it could get heat into all of the other rooms. I think
because of the air circulation, it is fine in the room it's in, the dining room.
Is up to 20 already. Exactly.
Once it's in there, because you're so well insulated, it will maintain the heat, hold the heat, won't it?
Yeah,
but initially it's got to get in there, and you're only getting very, very lukewarm heat going to those rooms for quite a few hours.
Yeah, and exactly.
It's got to build up and hopefully not escape.
Yeah.
But I'd put that on my phone, and I'd have just programmed on the phone. I want it on to be that temperature when I get home, and I just program the phone, and it would do it. But
I think I should have gone maybe for that. I didn't have it. I don't think I was given an option by my installers. But in retrospect, I would have gone. And for clients that I'm advising now, some of those are interested in air to air, and I'll certainly say I would go for the next level up.
I'd always go for, say, the middle range, maybe the top. It just depends what you want out of it, and the installer will tell you that. The bottom range is really a budget thing, and all the brands. And if you just want some cooling or heating now and then, it would do the job. If you want a bit more control over it, you need to go middle or top. And I can do you a good part exchange on that unit, by the way.
Oh, good. Thanks.
Well, while we're talking about low budget, Michael, you and I know there's this thing that exists in sort of the air-to-air world with DIY installs. So obviously, I understand, and you've mentioned John Eubank. So I chat with John quite a bit, and I introduced John to some people at the energy department, and I also introduced Tristan, and we'll talk about Tristan and OEM in a minute. So obviously, as we know, Michael, people can buy this stuff off the internet, and they install it themselves. Now, you and I know that can go wrong, because after a year, you get people phoning up my cousin. Well, I've put this unit in, and it's not working now, and there's no gas in it whatsoever. Because one of the problems that happened in this industry. So a lot of people will moan about China because most of the world's stuff is made in China. Now, there's a paradox here, because everyone sort of says, oh, well, it's made in China, it's rubbish. But that's not quite true. Some of the best stuff in the world is also made in China. It's just got to be quality controlled. So all all of the manufacturers that we're used to have stuff made in China. It's just that over the years, over the decades, they've quality controlled what comes out. Now, a very interesting thing happened. So let's say one of the big HVAC companies went to some of the Chinese factories and said, right, here's the spec for something we want made. Can you make it? That factory goes, yes, we can. And they do. Now, what happens though as well is another factory will get that spec and they'll look at it and then they'll reduce all the tolerances. They'll take copper out here and make things thinner here and all this sort of stuff. And they'll make exactly the same unit in their factory. And then they will call it something like powered by Toshiba or powered by. So that's all for the listeners. If you ever buy anything powered, I wouldn't. So what they've done is they've copied a Toshiba unit and then they've put powered by Toshiba. So it's exactly kind of the same stuff that the Toshiba unit's got in it, but they've reduced all the tolerances and it's crap, and especially with the fittings that everyone's connecting to, they're crap, and that's why you get a lot of the leakage. So I'd never advise anyone to buy anything cheap off the internet if it says powered by, and possibly not buy anything cheap off the internet anyway, full stop, if it's too cheap. Because that's, as you know, that's a problem, isn't it, Michael?
It's definitely a problem. We've often had customers say, "Oh, I've bought this unit from a certain company I won't mention." But, they say, "I've put it in. I just need you to come along and gas it up," even though often they're pre-charged, and sign it off. The answer is always no, but we do sometimes ask for some photos of their installation, which are really comical, and there'll be a lot of them on certain Facebook groups. So the way they've got a pre-length of pipe, 5 meters of pipe, they can't cut it and flare it because they don't have the tools. So they use what's there, but it's too long. So it'll just be wound up somewhere or in the wall. I saw one in the wall in a wall where there was insulated the other day. It was a curled up S shape because they needed to get rid of the excess pipe. And you see them, oh my God, you just don't get involved, but they're so comical. But they will cause problems to the next homeowner when he's drilling a hole in a wall to put a picture up, and all of a sudden there's this loud hissing noise. And if it's on heating, there'll be potentially 40 bar of pressure coming out of some refrigerant. Even worse if it's LPG, R290. So yeah, they are sort of banned from DIY sales, but you can still get them quite easy on certain sites and from certain importers. It's not tightened up.
And I understand why some people that are very interested in this industry and very interested in heating kind of want to do their own install. They're trying to reduce the cost of it. Someone like you or my cousin would charge. I get it, but I don't advocate for it. I understand why people want to do it, and there are some competent people out there that have got good engineering skills. They're not qualified in F-gas or anything, but they've got great engineering skills. But as yet, I don't advocate DIY stuff because obviously I've sort of grown up in the industry. But I do see a lot of people are really interested in this stuff. They want to put it in themselves, and they've gone out and got the tooling, and some people actually are even going on F-gas courses. But as you and I know, you can go on an F-gas course, but it doesn't necessarily equip you with sort of the understanding of this stuff, does it?
It doesn't. There's been a lot of conversations on certain Facebook groups that I spend a lot too much time on and talking about this stuff. Oh, you can learn your trade in 5 days. Well, you can learn some of it in 5 days, but there's no experience there. And learning it in a classroom is not anything like doing it in someone's property. It's completely different. And you're not working on a bench in someone's house. You're working on a bench in the classroom. You can pick up some basics. You cannot be a aircon or refrigeration engineer in a week. Even if you've got your F-gas. F-gas doesn't mean a thing for qualifications as in experience or what you're able to do. It just means you may not make a leak if you do a brace joint wrong or something because you've had the training apparently, but it's extremely basic. It's like the CBT for riding a motorbike. It's compulsory basic training. Doesn't mean you're experienced and you can ride a bike safely. It just gets you through the real basics.
I'm going to have to ask you now, do you ride bikes?
I did do my CBT, and that's as far as I ever got.
Oh, because my cousin who I talk about a lot, he's 76, fridge engineer. He did retire last year, but he's got an Augusta Brutale street bike. So he loves his Italian stuff. So he's had Ducatis, he's got a Maserati, he's got a Augusta
I like
Brutale.
4 wheels.
Yeah, yeah,
preferably four-wheel drive.
I do. Now we're going to go back to this noise issue again because a question that comes up about noise is obviously this whole thing of noise has impeded people getting domestic air to water heat pumps into their homes. You know, with sort of permitted planning and all this kind of stuff and planning. And a lot of people always say, well, why did this stuff have all this restriction around noise? And because gas boilers and oil boilers can be noisier. Now, you and I know, Mike, back in the early days, and I just sort of verified this stuff was noisy, wasn't it? Some of these outside fan cores could be
Oh, yeah.
blooming noisy, couldn't they? And I think that's
Oh, yeah,
where this
you've got
whole thing.
inverters coming about. Yeah,
Mm,
fixed speed on and off condensing units could be quite noisy. The initial startup could be a
mm.
loud thump.
Well, they were the
The fans could
capacitors,
be
weren't they?
noisy. But nowadays, yeah, they're all geared up to be very quiet,
Mm.
and they are quiet. If you put them in the right place, or if you size them up properly, they will be quiet in all of them. But it's where people seem to put them, and they're not put in by often. They're not put in by refrigeration engineers or aircon engineers. They're put in by, oh, let's say, plumbers or people with heating experience, but not enough heating experience in heat pumps. Fine if they want to put a boiler in, they know everything about it. But putting a heat pump in, you need to be a bit more of an aircon type engineer. You need to know about the product, and there's quite a few people I know of who do know about both of those things. But a lot of the newer people, or people who do work under grants in particular, don't really have a clue. Bung it in, run away, put another one in somewhere else, run away. I mean, we come across that about 4 or 5 times a week. Poor installs, and they're often noisy. And it's how they've been put in or where they've been located. But if things put in properly, they are quiet.
Mm.
So noise is not an issue for most of them. You need it put in by the people who know what they're doing.
Ed, are you going to think about maybe putting another mini in, like for the upstairs, or you're just happy how it is?
No, it's fine how it is.
Yep.
I wouldn't put a second one in our house.
Mm,
I mean, I think a big attraction of the unit for us was that, we'd put so much effort and money into making the fabric of the house amazing, that one thing that's attractive to me about mini splits is that you're getting similar performance in terms of SCOP to a air to water system, but it's radically cheaper, and it only really works in that kind of single unit mini split. It only really works if you've done radical things to the fabric, I would say. Like, it only really works to deliver heat in one room if the heat demand of all your other rooms is tiny. And so that's nice to be able to say, well, the money we've saved, the money we saved on our heating system has more than paid for our ventilation system, and that's a nice way of looking at it. Uh, so I wouldn't put in our house. We don't need an upstairs one. The one thing that I would say that I knew this was a problem when I designed the house, um, and I can't really think of a way around it until one of the children moves out, is that my office where I'm sat now, and my wife sometimes sat next to me, is in our bedroom, and a bedroom temperature of 18 degrees is great, but an office temperature of 18 degrees is less great. And most of the winter, that's fine. Like, the bedroom's 18 degrees, and then you get up and you open the door, and the bedroom quickly gets to 20 degrees. But when it's like really, really cold, it takes longer to warm the bedroom up. So, yeah, maybe occasionally, I haven't done yet, but I think occasionally you just plug in a small direct electric heater for that small amount of warmth you need in the office. But no, we don't need a second unit upstairs here. That's maybe like, if the U values in our upstairs are much better than downstairs, so that the walls downstairs are 0.27 and upstairs they're like 0.11, 0.12. So maybe part of the reason it works very well is that the floor where there is no heating, it's just heat leaking up the stairs, is much better performance. So I've got a couple of retrofit clients that are in two-story houses, bigger than this one. They're interested in using an air-to-air system. And possibly on those, I'll suggest having an upstairs unit as well, so having a two indoor units. because they're not doing any new bits, so all of their fabric is going to be retrofit, and the U values are going to be relatively high. But for this house, no, it works really well as a single unit.
Are the passive house community sort of becoming more aware of air-to-air stuff?
I think so, yeah. I mean, actually, Wolfgang Feist, who is like one of the original founders of Passivhaus, the original Passivhaus that he lives in, which is like 35 years old, I think. Um, I think originally it was heated with direct electric in the ventilation system, so the heat was delivered via the supply air. And actually, the 10 watts per meter squared requirement for Passivhaus is related to that, being able to deliver sufficient heat through the supply air without either increasing the ventilation rate above what you want it to be for air quality, or getting a kind of burnt smell. You know, if you have too much heat, if the heating element in the supply air is too hot, you get a kind of pyrolysis smell, don't you? And I think that worked out at about 10 watts per meter squared. So originally, I think I'm right in saying that they were using direct electric to heat their passive house, and they've retrofitted an air-to-air mini split, I think, in theirs. And then, so I was encouraged by that. I was encouraged by there was an Enefit in Greece, I think, that had written up that they'd done it, and they said it worked well. And partly I just thought it'd be exciting, it'd be exciting to see if it works, which you know, it's worked out well. But yeah, I was pretty confident it would work, and actually, it's actually worked really well. So yeah, I'm happy with that. Um, and there are, you see a lot of passive house projects where they're putting in air to water systems, and they're nervous about doing something as radical as not having radiators in every room. And I think that's a shame. Like you don't need radiators in every room if you've got really, really good fabric. And they could be saving themselves, 10 grand on their heating system and get something that's comparably efficient, or potentially more efficient, because it's you'll understand that it's difficult to measure the heat output, so I can't get an accurate SCOP, but I'm monitoring the electricity usage, and I can kind of reverse engineer that back to the modeled heat demand, and that looks like I'm getting a SCOP of between 4 and 5, which is really good. Um,
Mm.
I think if I was getting much more than 5, that would be hard to believe from like a thermodynamics point of view. And if I was getting much less than 4, that would suggest that my fabric was much, much better than the modeling suggests, which sounds unlikely. Um, so I think it's somewhere between 4 and 5. And you obviously can get air to water heat pumps that will get a SCOP of high 4s or even over 5, the best ones. But you need really good people doing that install and the design of that. And there's potentially some, you'll know more about this, Nathan, than I do, I think, but there are some things that are tricky to do in terms of getting basically a 5 kilowatt heat pump is going to be oversized for any domestic passive house, because the heat load is going to be below 2 kilowatts, the peak heat load. And so there are some things you need to do to make that 5 kilowatt system work efficiently in a 1 kilowatt heat load house, or 1.5 kilowatt heat load house. And the thing that initially pushed me towards thinking about doing an air to air was that I spoke to local heat pump installers, and I couldn't even get them to believe me that our heat load would be below 5 kilowatts. They just, I think one of them said to me, I said, I want this 5 kilowatt heat pump because it's the smallest air to water you can get at the time. This is like 4 years ago. And they said, oh, we don't even install them on new builds. I'm like, well, you probably should be, and B, like, this house is going to perform better than a new build. And he didn't believe me that this house would perform better than a new build.
Just
And
go on to sorry.
and so I was like, well, if I can put in an air to air, like, there's much less design that has to go into it, isn't there? You just choose the size and you put it in, and then how you run it will have an impact on the SCOP. but there's not the whole, trying to work out the system temperature, trying to work out whether it's an open system, whether you've got a buffer, or all of that level of complication that I wasn't confident I was going to get them to do a good job, especially on a house that was much better performance than they would be likely to acknowledge, I guess. Yeah, sorry, Michael, go
on. Yeah, with the air to air, because they're quick to work. The size is not critical, but when it's air to water, it's critical they get them right. And we've got a contract with there's a housing estate not far from us. It's quite modern. There's probably less than 10 years old. They've all got 14 kilowatt heat pumps because that's the biggest that the builders, I think, could put in. But they're quite small properties. They probably would get away with a 5 kilowatt, maybe an 8 in probably all of them. But I think it's the job lot been bought in because they've been used to boilers with maybe, say, a 20 odd kilowatt heat output, which is what most boilers are, 20 to 30. And back in the day with boilers, they just chucked a big boiler in. Any old radiators do flow temperatures of 60, 70, even 80 degrees. It will do the job fine. Not energy efficient, but it will do the job. So when they look at heat pumps and, it's only 14 kilowatts, it's tiny. So they just seem to go for the big heat pumps. And then they short cycle. They can be noisy because they're too big for the property. They're too close to the boundary, all sorts of things. And that's what a lot of people who are new to the air to water heat pump industry don't understand. It's all about the smallest possible and the lowest temperature you can have, preferably from underfloor rather than radiators. So
don't you start that debate up, Michael. Don't you start that debate.
I should stay off social media, I think, because I can't help but comment on so many people who just don't fully understand these systems.
Well, there's a big problem that's just been alluded to is so yet most people in the heating industry, so whether it's engineers, even all the way up to technical directors, I would argue are still struggling to understand the difference between temperature and heat. And as you've all said, we've all been used to the badge size on the boilers, and bear in mind, 1.7 million boilers have been going in every year. They're starting to slow down, critically slow down for some companies actually. But so in the engineer's mind, that 30 kilowatt is what the home needs. Now, ironically, lots of homes have never, even the homes built in the 60s, didn't need that because my granddad was developing and designing the burners that were going into boilers for the 60s, and you only had homes homes that were being built with no insulation still only had a sort of 8 to 10 kilowatt peak heat load. And like what I try and help people understand is, that radiator might have needed a mean water temperature of 75 for your outside design temperature. Let's say that was -3. But when a more common winter temperature of 9 degrees, then radiators only needed under 55. So everyone thinks low temperature heating is a new thing. Well, the laws of thermodynamics tells you it's not a new thing. It's just a home needs dynamic heat, because it's losing heat at a different speed. Whatever the temperature is outside, it's going to lose heat at different speeds. And this is a big problem. I mean, I try and help people understand that think of heat as speed, because it's that difference between two temperatures that makes it move different speeds. That's what that word "watt" means. It has the second already built into it. It's joule per second. So speed is very much, and unfortunately, and it's not. Is it engineers' fault or not? It's not really engineers' fault. They get trained to safely install gas equipment safely. They don't get trained in the science. You can argue they do a little bit at level 3 because I used to teach level 3, but they then forget it because they're not working with companies that sort of incorporate that knowledge. And the boiler industry, let's face it, they weren't bothered because our country became the most successful gas boiler industry on the planet. We were selling more boilers than any other country on the planet until 2016. Now, if you think about that for a little while, that's quite strange because we're a small planet. Yeah. We're a small country, and there's one reason and one reason only why we were selling more boilers, and that's because they broke down quicker than every other countries. Their longevity, because we were controlling, even though the condensing boiler got invented so we could use dynamic flow temperature and not worry about the heat exchangers and the water jackets rotting from condensate. That boiler came to the market in 1981 in the Netherlands first. that meant we could now push heat into the home at the correct speeds. But we still, to this day, and I've been a bit critical with British Gas recently, the two biggest boiler installation companies are British Gas and Boxed. They're still predominantly putting all their boilers in with fixed flow temperatures, with an on-off control. Now, that doesn't make sense. It just does not make sense. And that's why boilers don't last. If you're going to make a boiler go on-off thousands and thousands of times each winter, it's going to break down quicker. And also, because we're using high temperature flow rates, your rate of corrosion goes up. So we've got more systems that are corroding quicker. And of course, then we've got this industry, the magnetic filter industry, the most over-marketed component in our industry, which it isn't actually solving the problem. Reduce your flow temperatures, you help to reduce corrosion rates. So yeah, is it the engineers? There's a lot of engineers out there that just don't understand, what is or what a kilowatt is and what heat homes need. They're starting to. I mean, and obviously the people that's transitioned into installing heat pumps are absolutely loving the science now, and they're also loving the fact that some of their customers appreciate how scientific they have to be and how scientific this stuff actually is. It's not just a question of going in for half a day and putting a new boiler on the wall. Obviously, the boiler manufacturers loved that. They loved the people that were going out there and whacking a boiler on the wall in half a day, and they actually incentivized it. So if you look at all the big four manufacturers, especially, Valent would fly you abroad on a skiing trip if you sold their boilers, a certain amount of boilers in a year for them. And Ideal were flying people around to Vegas and Miami. 160 people went out to Miami or Vegas the year before COVID, because they were selling boilers. And so I'm quite dismissive of these loyalty schemes because it's just about selling. It's not about incentivizing people to become better engineers. But cool, don't get me on a rant again. But going back to your underfloor heating, Raz,
you're at your best, Nathan, when you're ranting.
I know. I mean, the reason I mentioned underfloor heating and radiators, so there was a problem I saw last year with underfloor heating companies stating in media, all the media we read, the industry media, trade media, how radiators require 70 degrees. And I had to say to them, what on earth are you saying? That's a complete lie. That just contravenes all laws of thermodynamics. A radiator needs what it needs, and that will change every day because your heat moving out the home is changing every day. So what you need into the home, and it's because they don't understand the difference between temperature and heat. We shouldn't have this rubbish marketing messages anymore. Not in 2025, but unfortunately we still have. But I'm going to stop that rant now. So it's been lovely chatting to both of you. Cool, that went quick, didn't it? We've been on here about an hour and 10 minutes, I think.
Okay, that's gone quick. That's surprising.
Anything you guys want to add? What would you like to see sort of happen in the industry, Michael? You've been involved in it a long time. Is there anything you'd like to see happen?
I'd like to see some of the regulation bodies scrapped, because I don't believe they're doing the job they're there for. I won't mention any names, but I think.
I was going to say, go on. No, I get enough trouble as it is. But
yes.
I mean,
we used to be MCS accredited for heat pumps and for solar PV, and it was just paying money, and all they did was it's just 99% paperwork. They weren't really interested in your job. They give no protection whatsoever to the customer. I come across that frequently. So that needs to change, especially as we're going down the route of all heat pumps should be done by an MCS accredited firm. And if we get these grants for air-to-air systems, I think that's a massive mistake. But if we go down that route, they'll probably have to be MCS accredited firms as well. At the moment, the people who do the job are not MCS accredited, they're not F-gas registered, they're just people who work under these sort of umbrella schemes, or one person down south might be accredited, the rest aren't. And I think it will cause a lot of problems for the homeowners. It's already doing that, and I think it's causing problems for the heat pump as a decent way of heating your home. People are thinking, heat pumps don't work. It's such a popular phrase I hear. And I think it's down to the accreditation.
Interestingly, can I pick up on that point? Because obviously the consultation is going on at the moment about getting air-to-air involved in the bus grant or the grant or any grant. You don't think that's a good idea?
I don't, because you need to be F-gas ready to put them in and buy them for a start. You need to know what you're doing. It's different to just buying a self-contained monoblock air-to-water system, which most people who put them in can't even repair them or service them legally. So that's a waste of time as well. But yeah, I think it will cause more issues than it ever solves. I think if we reduce the price of electricity to what it should be, as it's so easy to generate and transport, bring it down to the price of gas, for instance, that's complicated to get and transport, then I think that will solve a lot of issues. At the moment, a heat pump has to be 4 times more efficient, roughly, than a gas boiler to cost you the same to run it. But if we brought the prices down, heat pumps would be so cheap to run, then because electricity will be 7p a kilowatt hour in peak times, then lots of people would go to the heat pumps because they know it's going to be cheaper to run. And even if it doesn't work as well as they'd hoped, it would still be cheap to run. At the moment, it has to have a COP of 4, otherwise they're just equal. And a lot of air-to-air heat pumps are 5.5, so they're quite high. Air-to-water, a bit lower, but only if they're put in right. So,
I'd like to pick yours and Michael's brain while I've got you here, I think. First of all, like Michael, you said a cup of 5 or a little bit more than 5. Do you see air to air as being more efficient than air to water generally?
it is.
You think it is? Okay.
Because first.
Yeah, I've spoken to.
It's got water pumps in it, which there isn't on air to air. You've got the fan in your indoor unit, which is about 20 watts, if that. So there's nothing. Whereas air to water, I've come across systems with 4 pumps in them. They always, they nearly always need 2, but they often have had 4. If you've got radiators and underfloor heating, I've seen them all in operation. That's 400 watts, just pumping the water around. Air to water has to heat water first. So every time you heat something, obviously you lose some energy.
Yeah.
Something's wasted to heat that product up first. Then it's got to be distributed around your circuit with pumps. So air to air, in nearly every instance, will be more efficient. It's direct heating.
Okay, that's interesting. So the other question is, I've kind of viewed this from my experience with my house, and the fabric of our house is really, really good. It's exceptional, and I kind of view it as a really good solution for a house like that. Are you of the opinion that like a multi-split unit can work on less high performance homes as a main source of heating?
I know it does, because every home I've been in, every home I've owned rather, which has been too many. Hopefully we're not moving again. I've put a air-to-air heat pump in. Sometimes they're ducted, sometimes they're low wall, sometimes they're high wall units, mostly high wall units. And they always work really well. And we've got a lot. That's another big market for us. Is a lot of homes are after a multi-split or 2 multi-splits to do all their space heating. And we've been quoting for quite a few recently. It's quite a big market, that is. There are people who just have 1 or 2. I know yours does all your house, but most of them, they want them in 1 or 2 rooms, maybe the bedroom and maybe a lounge or lounge diner, kitchen diner. But there's a lot of people who are just having multi-splits to heat their whole homes. We've done a lot of those, and they do work well. And I've got a lot of good feedback from them. And those homes are just insulated as built.
Yeah, and once you go to that, like obviously there's a massive cost saving for my unit, although it meant that we didn't get any grants. Once you go to a multi-split system, are they getting towards a similar price to an air to water system with all the plumbing that's associated with that, or are they still radically cheap? Are they still a lot cheaper?
They can do, but the advantage is a lot of people these days are looking for a bit of aircon as well, which you can't really get from air to water, despite what people say. You need fan coils for air to water to do any sort of cooling. You can't have radiators running cold to do aircon. You have a soaking wet floor.
Rusty rags. And then the final question I've got for you is, I can never quite get my head around, like on a on a monoblock air to water system, how long the pipes between the outdoor unit and inside the thermal envelope of the house, and how well insulated they are really important in terms of the total efficiency of the system, because your heat
Yeah.
losses to outside are large. On a split system, those refrigerant lines between the outdoor unit and the indoor unit, are they ambient temperature, or are they warm? Like, does it matter if they're insulated or not?
They'll both be warm.
They are warm.
But there
Okay,
will be
that's what I
heaters,
thought.
and that's why most installers fit them in trunking, because then
Yeah,
it's okay. The trunk is minimal insulation, but it does protect against the wind taking
yeah,
away the heat, and it also protects from UV and birds and mice pecking at the insulation, because they
yeah.
do that.
So
But I think the
I did a
shortest possible run you can have.
yeah, in my
before
house,
getting
we bored it straight into the house, and then it
yeah,
runs up the service cavity.
it's
And
best
the,
way.
the installer would have run it up the outside of the house, and I was like, no, no, these
No,
lines are going to be warm. We want them to get into the house as soon as possible.
might as well have that
Um,
heat that would be lost inside your house.
Absolutely, yeah, yeah, yeah,
But not everyone wants to see something in their house, so not everyone's got a void they can run them
yeah,
in.
yeah,
So
yeah,
it
yeah,
depends what the customer wants
yeah.
at the
You,
end of the day.
you picked up on something quite interesting there, Michael. So I think people are realizing they want cooling. Or in essence, it's heat removal, isn't it? They want cooling because even I mean, I'm sitting in a relatively modern. Well, it was built 20 years ago. This is my brother's house, but this will get super hot in the summer. I mean, because what people don't realize, and we'll chat to you about this as in a minute. It heat moves to the lowest temp. So if it's really really hot outside, that's moving indoors,
Yeah,
and it's actually very uncomfortable if you get too hot. I mean, if you're cold in a home and you're able, I mean, obviously that the elderly probably struggle with this, but if you're able, you can put lots of clothing on. You can sit under a duvet with a hot water bottle. You can keep yourself kind of comfortable. When it
yeah,
gets really really hot, that's actually hard to do. I mean, I'll tell you what I do. I mean, lots of people don't like. I wring out a t-shirt and just put it on because that uses the laws of heat. That's actually, yes, in
that's,
essence, a refrigeration system now because of
it
vapor
is.
compressed. But and that keeps me nice and cool, and it's not as uncomfortable as what people think. But this cooling thing, I think, is becoming a bit of a market. People think, crikey, right, these things can do heating and cooling, can they? Oh, right, let's put
Mm.
one in.
Yeah, yeah, yeah.
Well, we used to do the air to air mostly for heating when we started about 30 years ago doing the modern type of air to air units that we have. Um, and we had quite a good market for heating only. And some people said, oh, that's like an aircon unit. I said, well, it is, but we sell them mostly for heating. So you can use it for cooling if you want, but you don't want it for cooling. They've wanted it for heating. Very few people have wanted cooling. Nowadays, I think the last, I don't know, maybe 5 to 10 years, the planet may have been getting warmer. Who knows what the reasons are? But we do seem to have very odd weather patterns. They're all mixed up. And
Scientists have a good idea, I would suggest.
yeah, I think I know what we are having, but not everyone agrees with it. But
Yeah,
it's getting warmer, and
yeah,
certainly the last few months have been exceptionally warm. The aircon market has boomed, and certainly the last week or so, or a week or so ago, when we had the low 30s, that's a horrible temperature because the body only really wants 21 as to be comfortable. Unless you're working, I mean, physically working, you want it less than 21. But if you're doing very little, 21 is more than adequate. Anything above that is you start to sweat and it's uncomfortable. Fortunately, I do have aircon at home, not like you do if you need it. And we use the aircon at home, and we also use aircon in one room, heat pump on the other on some evenings when the temperature is not quite as you want it in either room. And people don't understand it. Why have you got cooling on and heating? Well, if that room's not warm enough, we've got the heating on. And if that room down the other end, it's a long bungalow, if the other end isn't cold enough or whatever, we put the aircon on. So you can have them both on at the same time. And it's really about maintaining a nice comfort level. Because every car now, or nearly every car's got aircon. And often if it's a better car, it's got climate control. So just both heating and cooling at the same time. So people are well aware of aircon now. It's not something that makes you cold. It's something that makes you comfortable. It reduces the high humidity and the temperature. And so I think certainly in the last few years, weather patterns have helped the aircon side of things. But yeah, we only used to fit these for heating. We just happened to have that market.
Could you see more? Can you see, Michael, more AC engineers getting involved in the domestic? I mean, as you and I know, most AC engineers out there are commercial, and they don't want to go anywhere near domestic properties because that means they've got to get involved with homeowners. But can you see more AC companies sort of getting involved in a bit of a domestic? Because obviously you've been putting.
I think so, because I've seen quite a few. They seem to dabble in that a bit more. A lot of AC companies like the VRF stuff, because it's big money, 50,000, 100,000 pounds. It's not a market I've really been in, because to me, being in business is about cash flow. If you go and work in someone's house and you can put a system in the morning, it's easy money. You've been paid on the day. There's no chasing up. So they're the jobs we stick with. And I think a lot of those medium-sized companies will go to do the domestic installs, realizing that every building can have a heat pump. In fact, almost every building has got some sort of heat pump, as you know, Nathan. But yeah, they're relatively cheap now, and they work really well. They're really efficient. So I think there will be more companies doing AC installs in domestic properties. But I do think the market has really picked up, just from seeing stuff on social media. There's a lot of people who are doing it. What I'm not so keen on is there's probably a lot of small time, say plumbers or heating engineers or electricians doing their F-gas and doing aircon, and they may do it fine. I've seen quite a lot of jobs that do look fine when you see them on social media. There's a lot of people in that market, 1 and 2 man bands, who are now thinking, oh, well, we do the electrics in this house, so we can also offer them heating or cooling. We can put in 1 or 2 single splits, or even a multi-split. So I think that maybe it'll be more those people who are putting in the domestic stuff rather than some of the bigger aircon firms. But yeah, I've always felt, move with the times. What is the stuff we need to sell within our industry? So I used to manufacture. I manufactured up till about 1990. It's not worth it now because I can buy it from China cheaper. We used to manufacture bottle coolers for pubs, cold rooms. It's not worth it. You can buy it cheaper from, I've not always direct from China, but maybe sourced from those countries. So we need to be at the install end of the chain, and that's the aircon, the heat pumps. But we need to know what we're doing if you want to keep the product a successful product, which it will be for the right people are putting it in.
Before we go, Mike, well, another question I want to put to you is, you and I obviously have sort of gone around some very, very big manufacturer names, because some of these HVAC manufacturers are huge companies, huge entities. Do you think, there's a couple of questions in, I suppose, do you think manufacturers are doing all they could do to help the engineering community and the consumer community?
No.
I like that straight answer.
No, I think they could be doing some more with training, especially if they must know that there's lots of people getting into the market for their products. Do those manufacturers really want to have a poor name? Because that's what people say. They sell, oh, that brand's useless. And only because it's been put in by someone who doesn't really know what they're doing. And I think they need to do more training, more free training, some online, some at local centres. I mean, there are places that do training. So I think the manufacturers need to put some more into that, fund it, not just sell products, bang out the boxes, because I think it will come back to haunt them.
No, I agree. Now, as I did mention earlier, we'd speak a little bit about Tresidder and Glynn's OEM, which for most of my listeners will know, it stands for Open Energy Monitor. They run the heatpumpmonitor.org website. It's a fantastic site. I think it should have won awards by now. You're on it, and I think last year your system was the cheapest to run in the whole of the country that's being monitored. Is that right? Have I got that right?
Yeah, I think so. I haven't dug into it because there's some kind of other little things there, like our system doesn't include all of the hot water costs. So I think the reported amount that Glyn and Tristan reported was like £120 or something, or £113, something like that. And actually we've got the hot water cost on top of that. So but our total hot water and heating was 175 for the first 12 months that we had monitoring. Um, and and actually some of the air to air cost is actually heating the water because our hot water heat pump is stealing heat from the house, so it's increasing our heating demand. Um, so I think that 175 still, I think we're still the lowest cost of anything monitored on there, which is yeah, not I didn't expect that. Like, we're so far north, um it's interesting. Like, are we? Does that mean we've got the lowest heating costs of any house in Britain? Probably not. I don't think. Like, there should be. Well, there's probably someone living incredibly frugally and coldly who has lower heating costs than that. But there probably is also a passive house somewhere that's got a heat pump and isn't on open energy monitor. I certainly know that there's some like social housing new build passive houses where the tenants say that they never turn the heating on, and that they're comfortable all the time without that. So they'll be cheaper than us. But for a retrofit in quite far north in Scotland, I'm pretty chuffed with that. And we did do some quite radical things with the hot water as well. So like our hot water demand is very low for the fact that we've got 5 people in the house. We've got like wastewater heat recovery, a shower save vertical wastewater heat recovery thing on the ground floor, and that's serving both the showers on the first floor, and that's reducing our energy demand for a typical length shower. That more than halves our energy demand for showering. So that's good. And then we've got like a radial distribution for the hot water as well. So rather than having say a 22 mil pipe that branches at each outlet into a 15 mil pipe at each outlet, we have a short length of 22 from the tank going to a manifold, like less than a meter of 22 going to a manifold, and then each hot water outlet has a 10 mil single run from the manifold to the outlet, and the bath has a 15 mil because you want it to fill quicker, and that means you get super quick hot water, and your distribution losses are very low. Your heat losses and distribution are very low. So that's why our hot water demand is low, and that kind of feeds in. We were talking about overheating in summer. That feeds into our summer performance as well. The summer performance of the house is really good. Like in 28, 29 degrees, the house stays below about 20, max about 23, which is excellent without the air condition, without running the air conditioner. So it's interesting thinking about, like, moving forward, will we start to use the air conditioning? And I think there are two things that might mean that we do. The first is that the reason we're able to do well at the moment in those heat waves is it's cool enough overnight that opening windows at night brings the temperature back down to, say, 21 or 20, and then it'll go up to 23 during the day, and then you'll cool it down again at night. But if we start to get hotter nights where you're not able to cool it in the nighttime, then that would be one thing that pushes us into it. And then the other thing that I think could push us that way is when we get periods of warm, not necessarily the hottest weather, but very humid weather. So the last week, we had the very hot weather, and then it stayed really humid for a whole week, and the house was like 23 degrees, but mid 70s relative humidity, and that's feels uncomfortable because it's too humid. So I think maybe if we get a lot of that, I'll start turning the air conditioning on to dehumidify the air rather than because it's actually too warm. So that's scary from a climate point of view, but also kind of interesting from a building physics point of view.
Another question I want to ask you is, obviously you're sort of an expert in this whole world of insulation, being part of the passive house community. Have you seen, because as you probably recognised, if we go back a few years, anyone that's sort of very passionate about making our buildings more efficient or having heat into the home being put into the home more efficiently. This whole thing of fabric first. Everyone thought, not everyone obviously, but lots of people thought. Some people should have known actually better, but that you had to insulate a home to the nth degree before you can have heat pump. And as Michael's mentioned, you've put them in churches, Michael. There's a world famous church in London that we've put them in, and is the sort of insulation community sort of starting to realise, well, hang on a minute, you don't always, homes don't lose as much heat as what people think anyway. The average home, they don't need sort of these 20Ks, 30Ks that they're associating with their boiler. Have you seen that sort of attenuate this whole thing of like, well, you must insulate, you must insulate? Have you started to see a bit of a shift?
I don't know about in insulation world in general, but in the passive house world, in the passive house retrofit world, yeah, that's definitely getting large recognition that you don't need to have really good fabric for a heat pump to work, but with some really big caveats. Like if it's for a family who are fuel poor and they're going to run their heating system intermittently, then just sticking a heat pump in there, even if it's sized properly, is going to be a disaster for them because they're not going to be able to run it in an efficient way, and their bills will go up in that situation. So, I think it's been a shift in my understanding that you don't have for someone who's able to afford to run their heating system efficiently, you don't have to do insulation before you do the heat pump, and but so yeah, but we still need to be mindful of like how the system is, how people are going to run the system, and I think there is like these things can swing from one from too far from one way too far to the other, and I think there's a risk in saying all we need to do is heat pumps. I know that's not what, for example, Nigel is saying, but there's a risk that people start to say, oh, well, all we need to do for decarbonisation is heat pumps. But no, we also need to think about people's comfort, and that depends very heavily on the fabric. We need to think about people's health, which depends very heavily on the fabric, regardless of whether the house is warm or not. And we need to think about whether people can afford to heat them. And that's on a householder level. And then on a more big picture level, we need to think about the fact that we need to decarbonize the whole economy. And the faster we do it, the better, really, from a climate point of view, and also from a strategic point of view as GB PLC. Like the faster we move, the more advantage we gain in new industries. And and we need to decarbonize everything. So if you can reduce the heat demand of houses, then that's a good thing. Like it's not all we should do, but we shouldn't just look at doing heat pumps, I would say.
Yeah, it's a complex discourse, this one, because and there's another thing I actually see. I don't know if you see it. I see intermittently people putting on social media, and people that are in the sector in some form or shape or another, that their concern is with highly insulated homes that they overheat in the summer. We've obviously talked about in the summer. They don't realise that insulation is a barrier to it's slowing heat down, whether it's moving in or moving out. They think if you have a super insulated home, you're going to get hotter than the people that don't have a super insulated home. I mean,
Yeah, I mean,
do you see that?
yeah. But like all the best myths, there's a grain of truth in it. Like you're right that insulation slows the heat. Heat wants to move from where it's hot to where it's colder, and insulation slows the rate at which that heat moves. But and 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 so a well-designed, well-insulated house will perform better in hot weather than a poorly insulated house. But with a caveat that if you're not careful about solar gains, and if you're not careful about gains from hot water systems, those are the two biggies, but also appliances as well are important. But the two big things are hot water systems and solar gains, not in that order, probably solar gains is more important. If your solar gains and gains from hot water are too high, then your house will be too hot, even your house will be too hot, and you won't be able to, you can end up with a situation where it might be 30 degrees in outside, but it might be 35 degrees inside because you've effectively made yourself a solar oven. And in that situation, your your airtightness and your insulation are working against you. So it's difficult as a building physicist. It's always been difficult to get designers to take overheating risks seriously. And it becomes much easier for 2 weeks of the year when they're too hot. And you talk to them about overheating risk, and they're like, "Oh yeah, that's really interesting. What do I need to do here?" And that's maybe slowly getting easier to have that conversation. But a well-designed, super insulated, airtight house with heat recovery ventilation performs like it's almost more impressive, I think, in summer than it is in winter. Because you walk in and it feels like you're walking into an air conditioned space and the air conditioning's not on. Um, but a poorly designed, like loads of houses around here, we've got nice views, and the default response from an architect or a designer to a nice view is to put a massive window. So, our nice view is to the southeast. So you've got like literally fully glazed gables in new built houses facing southeast. And you just look at those houses and they're going to be unpleasant to be in those rooms probably for 3 or 4 months of the year. It's not just when there's a heat wave, it's like whenever it's sunny, basically. So it's there's a grain of truth in saying that low energy houses have an overheating problem, but they don't have to if they're designed well. Like if they're designed well, they will outperform poorly insulated houses. But if they're designed badly, you've got more of a problem.
I mean, you've mentioned solar and cooking and your hot water, but obviously, if you had a little party, a little sort of way, I can never pronounce that word, but like 20 people turned up, you've got an extra 2 kilowatt of heat input in your home, and you've got to then get rid of that.
Yeah, well, actually, the first heat wave we had 5 people staying, 5 extra people staying, and we had 5 other people visiting, and we were cooking pizza, and yeah, I mean, even in that, uh, it was fine. Like we just opened all the windows, and the gain through the fabric is so delayed by good insulation that it was still better than a normal house. I mean, it was too warm. It was warmer than we wanted it to be, and we ate outside, but it would have been worse in the house before we'd done the retrofit, for sure. So yeah.
Final question before we all go is: you live you live right near Ben Nevis. Have you climbed it?
Oh, many times.
Oh, have you? Oh,
Yeah, yeah,
well,
yeah.
well done you. I've
So
attempted.
I'm a climber, so yeah.
Ah, well, there you go. Well, have you been climbing on the Isle of Skye?
I have climbed on the Isle of Skye, yes. Yeah.
Yeah, yeah, yeah.
It's a
So
favorite place
my my
of mine.
my eldest brother-in-law used to what he used to do? He used to teach the Gold Duke of Edinburgh Awards for climbing. And he'd take people out to sort of Mount Kilimanjaro and stuff like that. But yeah, I always remember him telling me about the stuff on the Isle of Skye. I've attempted Ben Nevis about 7 times, but always
Oh no.
got halfway up and then come back down. I mean, this was usually back in the 90s with my mates, and we were sort of inebriated, I suppose is the best way to put it. So we'd always decide to come back down. But gentlemen, it's been fantastic. It's a fantastic little episode. Just really enjoyed it. I think we've done about an hour and a half. Thank you ever so much for coming on. Thank you, Michael. And also a bit of a shout out. Been in the industry a long time, so thank you for that. It helps that we've had engineers like yourself in the industry. And thank you for coming on, Les, as well.
Thank you very much. Yeah, it's been a pleasure.
Good stuff.